The next rule is the sum and difference rules. Sum just means add, difference just means subtract. These are also kind of the same idea as the constant multiple rule. They're just saying things are along for the ride. So if we have a situation where we have two functions that are added together, and we're told to take the derivative of them. So let's say we have some function f of x plus g of x, and we're told to take the derivative. All that this rule says is that we take the derivative separately. Let me write that a little more neatly. Okay, I don't know if that counts as being neater, but derivative of f of x plus derivative of g of x. We just work with them separately. The same exact thing is true as subtraction. If we're subtracting f of x or we're subtracting g of x, same thing. So to give you an example of that, what we're looking at is, let's say that we're told to take the derivative of 3x squared plus 2x to the fourth. All we're going to do is take those two derivatives separately. Derivative of 3x squared plus the derivative of 2x to the fourth. When we do that, this 3 is along for the ride. Bring down the 2, subtract 1 from the exponent. Here this 2 is along for the ride. Bring down the 4, subtract 1 from the exponent. And there we go. If we have something like f of x equals x to the fifth minus 2x to the fourth, then when we're finding the derivative, we just treat them separately. 5x minus 1 from the exponent minus the 2, bring down the 4. 4 minus 1 is 3. Voila. So, I'd like you to do one on your own. Let's take the derivative of x to the sixth minus 7x to the third. Pause the video now. Okay, we're just going to take the derivative separately. 6x, subtract 1 from the exponent. The 7 is along for the ride. We bring down the 3 and subtract 1 from the exponent. That gives us 6x to the fifth minus 21x squared. There is one special case that tends to trip people up that I want to go over really quickly. And this isn't any different from the stuff that we've been doing. It's just looking at what happens in this case. We're told to take the derivative of 3x. Now, we know that our power rule, is to take down the exponent, bring it down, and then subtract 1. But right here, we don't see an exponent. The thing to remember is that this is an invisible 1. So what we're doing here really is we're saying this is 3, bring down the 1, and then subtract 1 from the exponent. 3 times 1 is 3. 1 minus 1 is 0. And then remember, anything to the 0 power is just 1. So when you have a situation where you have 3x or 4x, or just sort of that linear function, then it's really important to be aware. This x is just kind of going to go away. And this makes a lot of sense because what we have is we have a linear function with a slope of 3. And when we take the derivative, we're asking what's the derivative of this curve? Well, the derivative of this curve, it doesn't matter what x is, it's always going to be 3. And that's why we see this. So either way that you think of it, just make sure that you aren't tripped up by that one. So if we see a similar example, we're just going to remember we bring down the 1, subtract 1 from the exponent. So this is now x to the 0, or just plain old 1, and it's 5 for the derivative. We can also think of that as it's a line with a slope of 5. The slope is always 5, so the derivative is 5. It doesn't matter what the value is for x. This is not something that's that hard to do. It's just really hard to remember it when you're sort of in the mode of doing other things. So let's do some final practice problems, our checks for understanding. And I'd like you to do the following. I'd like you to take the derivative of 3x to the 4th minus 2x plus 1. Try that one on your own and restart the video when you're ready. Pause the video now. So the first thing to remember is the sum and difference rules, simply that when these are added and subtracted, we just treat them each separately. And we also remember that the variable here is just along for the ride. So we'll look first at this one, the 3 is along for the ride. Then we use the power rule, bring down the 4, subtract 1 from the exponent. Now here, this negative 2 is along for the ride. This is x to the 1st power. When we bring down the 1 and subtract 1, this is x to the 0, and it goes away. So it's just negative 2. And then the derivative of any number, that constant, that's 0. Another way to think about this is we could think about this as 1 times x to the 0 power. When we bring down that 0, anything times 0 is just 0. So there we go. So when we simplify this, we get 12x to the 3rd minus 2. Let's do one more and we'll be at the end of the notes. If f of x equals 6x to the 3rd minus, let's say, 5x plus 1 over the square root of 59. Let's find f prime of x. Pause the video now. Same as above, we do each one separately. This 6 is along for the ride. Subtract 1 from the exponent. This negative 5 is along for the ride. We bring down the 1 and subtract 1 from the exponent, so this is x to the 0 and it goes away. This is 1 over square root of 59. It's just a constant, it's just a number. The derivative of a number is always 0, or we can think of this as x to the 0 power, bring down the 0, it becomes 0. In any case, when we simplify all this, we're going to get 18x squared minus 5. That concludes the notes.